In this video, we're going to take a look at the different types of chemical reactions. They're classified based on patterns that they appear in or occur in. The first two we'll take a look at are opposites of each other. They're called synthesis and decomposition reactions. Synthesis just means to make. It's when two or more elements come together to make one bigger one. So A and B come together to make AB. They're now together. Here we have hydrogen plus oxygen making water. So it would look like H2 plus O2, two things coming together to make one, a synthesis reaction. Whereas decomposition is the opposite. One big thing reacts to make smaller things. So breaks down instead. Synthesis is to make, and decomposition is to break. So we have water would break down to make H2 plus O2. And so for now, if I give you a chemical reaction, chemical equation, I'd expect you to be able to classify it as synthesis or decomposition. So you can pause the video and try to classify the following reactions as such. So if we take a look here, we have two things coming together to make one, so synthesis. Here, one thing is breaking down to make many, so decomposition. Here, synthesis. Here, decomposition. Here, it looks like a synthesis, synthesis. Now it's the same idea, but with words this time. So pause the video, try it, then check your work. Tin iodide is a compound, breaking down to make tin and iodine, two separate elements. So we have a decomposition. Here we have two elements making a compound, so we have a synthesis. Here again, two elements making a compound, so a synthesis. Here, two elements making a compound, so another synthesis. Here, a compound being broken down into two smaller things, a compound and an element. So we have a decomposition because one thing, now many things on this side. And here, many things on one side, making one big thing, so we have a synthesis. Then you might also see problems like this, where you have to convert things into word equations and balance equations, and then determine the type. So really there's nothing different here other than just telling me the type based on the pattern you see. So potassium reacts with fluorine to produce potassium fluoride. So we have potassium plus fluorine, and that makes potassium fluoride. You can probably already tell from the pattern that many things are making one bigger thing. So that would likely be a synthesis reaction. If you want to make a balanced equation, we have K plus F2. Don't forget that's gas because it's one of the diatomics. Produces potassium fluoride with crisscross. To balance it, we need a 2 over here and a 2 over here because that makes two F's, two K's, two F's here, two K's there. And now it's balanced. I'll just put a 1 there to show I'm done with the balancing. So nothing's different here. You've done word equations before. You've done skeleton equations before. The only different thing is I'm asking you to tell me if it's synthesis or decomposition. Let's try this other one out here. So we have aluminum reacts with iodine to produce aluminum iodide. So try it yourself. Pause the video and then unpause and check your work. So we have aluminum reacting with iodine, and it's producing aluminum iodide. You can tell that's two things making one. So we have a synthesis again. If you want to make a balanced equation, we have aluminum, that's Al, plus iodine. Don't forget that's I2, and it's a solid because it's one of those diatomics, Hofbrinkels. And then aluminum iodide, so Al, I3 with the crisscross. If you want the balance, it looks like you have 2 here, 3 here, so 6 is a common multiple, so we'll do 2. That'll make 6 I's, 2 Al's. We'll do 3 here, that makes 6 I's, and we'll put 2 over here, that makes 2 Al's. So now we're balanced. It's a balanced equation, synthesis. So you make your skeleton first, you balance after, and you can determine your type. Try this last one here, check your work. So we have aluminum iodide breaks down to form aluminum and iodine. So it looks like the opposite of the above one. So right away you should be able to tell that it is a decomposition. So aluminum iodide is breaking down, so it's decomposing to form aluminum plus iodine. Writing your balance equation, we have aluminum iodide, so Al(I3) produces aluminum plus I2 solid because it's soft wrinkle, but you can see this is a decomposition. So in this video, all we saw was how to identify the difference between a synthesis reaction and a decomposition reaction. We did some practice identifying, practice writing word and balance equations, and then classifying or identifying the type from there. In the next video, we'll learn how to classify single displacement and double displacement reactions.